Okay, so last section in chapter 1, 1.6. It's on different operations you can do with functions. And the idea is to take two functions you already have and combine them together to create a new function. And there's different ways we can do that. One way to combine two functions that are separate into one function is to use any one of the four basic operations. We can take two different functions and add them together, subtract them, multiply them, or divide them. Okay, another way we can combine functions together is composition. Okay, so that'll be the last thing that we look at. All right, so here's two different functions. Okay, f of x is x squared, and g of x is the square root of x plus 1. If I wanted to take f of x and g of x, combine them together to create something new, one way I can do that is with addition. I can literally just take x squared and add it to the square root of x plus 1, and now I've created a new function. It's just the sum of the two that I had. If there's anything I could simplify, I would. There's nothing you can simplify there. But if f of x was like 3x and g of x was, I don't know, 5x, if those were the functions and then you added them together, that you could simplify to 8x. Okay, but in this case, there's nothing you can simplify. How about if I divided them? Colin, what would it look like if I took f of x and divided it by g of x?
Exactly how you have it.
Yeah, so can you tell me what I would write right there?
Just being x.
X squared, yeah. Divided by? Well, what's the denominator?
G.
G of x. And what is g of x?
X times square root of x plus 1.
Square root of x plus 1. Okay. Just take f of x divided by g of x. So now you've created a brand new function by dividing the two that you had. Okay, that's all. Okay, and there's more examples of that on page 58 in your book. Okay, but any questions on that? Okay, so just combining functions. And we're gonna look more at what the effect is on the domain and the range when you do that. So you might know the domain of f of x and the range, and you might also know the domain and range of g of x. But when you take the two and combine them together to form something new, the domain and range can change. That's what I want to take a look at. Okay, so how do you find the domain when you create a new function? Well, the domain is basically all x values that belong to the domain of both of the original functions. So the domain, when you combine two functions together, like we're doing with addition, subtraction, multiplication, or division, is all x values that work in both original functions. Right, so if we look at f of x was x squared, can someone tell me what's the domain of x squared? What numbers are you allowed to plug in for x and square? All real numbers. You can square any number you want. Now, with square roots, what kind of number, when we take a square root, we have to make sure that it's at least what number or higher? You can take the square root of a number smaller than 1. You could do like a half. So what's the smallest number we can take the square root of? 0. So the domain here is all real numbers. There's no restriction. The domain here would be all x values that make what's under here at least 0. So what could you pick for x values? You could pick 0, -1. You can pick any number from -1 and up. Because if you do -1 plus 1, you get 0. And we just said that's okay. So domain here is all numbers greater than -1. Greater than or equal. So now when I combine them to get that function, I have to pick x's that work in both. Well, in this part, you don't have to worry about anything. You could square anything you want. But this part, you can only pick numbers greater than or equal to -1. So you can only pick numbers greater than or equal to -1 for the whole thing. It's got to work in both. Now, the other thing you have to be careful about, besides making sure you're not taking the square root of a negative, we just said that, you have to make sure when you combine functions together, you didn't create a situation where you could divide by 0. So that one you got to be careful if you combine functions with division. So if we look at that one I just circled, f of x divided by g of x, is that a fraction? Yes. Is there a variable in the bottom of the fraction? Then somehow you could divide by 0. What would you have to plug in for x to make that denominator 0? -1. So if you plug in -1 plus 1, you get 0. And what's the square root of 0? 0. That part's okay. You can plug -1 into the square root. But now the problem is going to happen when you do the division. You would be dividing by 0. So this one is not a domain of every number from -1, including -1 and higher. It's just the domain from -1 to infinity, but you cannot include -1. Does everybody see why you can't include -1 in the second one? But you can in the first one.
Wait, can you say that again? Why can't
You can't include -1 here because if you plug it in, you're going to divide by 0. -1's not a problem for the square root. That part's okay. But then it's in the bottom of a fraction, which would be a divide by 0. Okay, so those are the two things to watch out for. Square roots of negatives, dividing by 0. Okay, well, let's try this one. Two functions, and I want to just literally write down what f of x plus g of x would be. David, can you tell me what I would put for f of x plus g of x?
Square root of x plus 2 plus the square root of x minus 2.
That's it. Nothing you can do with that. You can't combine that in any way. That's it. And now the domain. Well, let's start with the domain of the originals, and then we'll figure out the domain of the new one. Kelvin, what kind of numbers could I pick for x in f of x so that I never take the square root of a negative? Exactly, -3 and above. You can pick any number from -3, go as high as you want. Braden, how about in this one, g of x? Well, if you pick -2, what's -2 take away 2? That's plus 2. So -2 take away 2 is -4. You'd have the square root of a negative. So we can't go as low as -2.
So I want to go to
2. Yeah, you could pick any number, but it's got to be between, or it's got to be higher than 2. Okay, like if you try 1 minus 2, that's a negative. So now the domain of my new function is all x's that work here and here. So what x values could I pick so that they work in both? 2 to what?
Infinity?
2 to infinity. Yep. Even though technically you could plug in a number 0 here, and it would work fine. 0 plus 3, you can take the square root of 3. You can't plug in a 0 here. It wouldn't work. Okay, so it's gotta work in both. So this time, 2 to infinity. Any questions on that?
I have a question on the bracket thing.
Bracket means including the 2.
Oh, including the two, okay.
So I think we did a little bit with that on the graphing, but if you put a parenthesis, it means not including.
Okay.
Parenthesis on infinity means I can't reach it. So I can't include it because I can never get there. If I did something like this, that would mean everything from 2 to infinity, but not including 2. Like 2.00001 and up. Okay. All right, let's try this one. F of x divided by g of x. So Ian, what would I put for f of x divided by g of x?
The square root of x plus 3
Yep.
divided by the square root of x minus 2.
Divided by the square root of x minus 2. Now, we already have the domain from the problem when we just combined these functions earlier. So the domain of our new function we just created has to be at least this, or maybe it's even a little more restrictive. This function can't include anything that this one didn't. Okay? So we're already only thinking about 2 to infinity. But does anybody have any thoughts about using the same domain here? It's almost the same domain, but not quite. Yep.
We use the same domain on the numerator.
Okay, you could use any number from 2 to infinity in the numerator. How about in the denominator? Could you use any number?
You can't do 2, it has to be, there should be a parenthesis instead of that, but it has to be bigger because you can't divide by 2.
Right. It's not that 2 is a problem with the square root. You can plug in 2 for x and take the square root of 2 minus 2 and get 0. The problem comes now you have to divide by 0. So the problem is with the fraction. So you could pick any number from 2 to infinity and plug it in for x. All right, let's try this one. Let's graph. This is one we're just going to graph it. And it says to take f of x divided by g of x. All right, so f of x is absolute value of x. Okay, and if I haven't shown you where absolute value is, it's under math, number, and it's the first option, absolute value. All right, so absolute value of x, and then divided by x. So let's just try one by hand. What if you plug in 2? What's the absolute value of 2? Divided by 2. 1. Let's plug in 12. Absolute value of 12? 12. Divided by 12? 1. So you're going to get 1 for the answer, a lot of the time. Let's try like -5. What's the absolute value of -5? 5 divided by -5. -1. So when you hit graph, if you plug in a negative value for x, you always get -1. If you plug in a positive value, you always get +1. So those are the only two numbers in the range. Those are the only two numbers you'll ever get for y. 1, -1. How about the domain? What numbers are you allowed to plug in to that equation? Absolute value of x divided by x. Yeah?
All numbers except 0.
all numbers except 0. You can plug in anything, you just can't divide by 0. So pick anything you want from negative infinity up to 0, but you can't include 0. Or, that's what that symbol means. Technically it's called union. Or you can pick anything from 0, but don't include it, to infinity. That's how you write all numbers except 0. Okay? Any question on the domain and range of that one? A little different, just because of the way it looks. Yeah?
If I just wrote all numbers except 0 on a test, would you mark it wrong?
If it just says write the domain, no. If it said to write the domain using, like, this is called set notation, then you would have to write it in set notation. So only if the directions ask for that. Yeah. Okay. Any other questions on that one? So let's look at composition. So I showed you how to combine functions. We did some addition, we did some division. You could do subtraction and multiplication as well. But composition is another way. Anybody remember composition from algebra, probably algebra 2? Remember that? No? So let me show you how composition works. So idea of composition is you take one function and plug it into the other one. Okay, so here's the notation for a composition. G of f of x. That's how you read that. Now, if I wanted to find, say, I don't know, g of 9, what would that mean to do? If I want to find g of 9, what do I do with the 9? Plug it in where x is into, the function g. Take the variable, replace it with what they give you. Well, composition is exactly the same thing. Take what they give you and plug it into the function. So take what they give you for f of x, so this time it's not numeric, it has a variable, and plug it in for the letter. Okay? That's composition. Taking one function and plugging it into another. So, g of f of x would be the square root of x squared plus 3. You cannot simplify anything there because of that plus 3. If the plus 3 wasn't there, then I could cancel a square and a square root. But you can never cancel a square and a square root if there's plus and minus with it. Okay, let's try it the other way around. Anyone think they could tell me what f of g of x would be? Mina?
The square root of x.
The square root of x. What else? Because you're plugging, now you're taking this,
X
putting it right there.
plus x squared plus 3.
Yep, the square root of x squared plus 3. Because now you're taking what they give you for g and filling it into function f. Now, anything that I can do here?
Wait, I have a question.
Mm-hmm.
Is it since? Oh no.
Take that, fill it into f. Is there but anything else I can simplify here? I can simplify the square and the square root because there's no plus with the x under the root. So what do I get? X plus 3. Now, when we describe the domain of a composite function, you can't forget that it came from a square root. That's important. Even though it canceled out in the final answer, it was still part of the original problem. So we have to take that square root into account when we find the domain. And that's what I'm going to show you how to do next.
So would you mark it wrong using the first answer? Or
The square root of x squared plus
yeah,
3?
would you have marked that wrong?
Nope, I would probably take off a point though, but it wouldn't be wrong. It's just you didn't simplify. So you would not lose full credit on that. Another symbol, and I don't use this symbol, but you might see it in the book. I always do it this way. But if you see G, a small circle, and an F, it means what I just circled. Okay, so we're going to stick with that way. All right, so how do you find the domain when you do a composition? Okay, it's 2 steps. The first thing you have to look at is what I call the inside function. Okay, I'm going to go back for a second. What do I mean by inside function? I mean this one. That's the inside function in that problem. So look at the inside function and eliminate any values that you can, or any values that shouldn't be in the domain of that one. So that's step 1. Eliminate any values not in the inside function. All right, step 2, after you've eliminated values that are not in the inside function, now look at the final answer. Are there any values you're not allowed to use in the final answer? Okay, so look at the composed function and see if there are any additional values you need to exclude. And now write your domain, excluding anything from step 1 and step 2. All right. First one we could, well, does anybody have a question about how to evaluate something numerically? Like this is exactly the one I told you, G of 9, how you would do that? What would you do first there? Yeah, Mike?
Place all the values in g of x on 9.
Yeah. Look at g of x and replace x with 9, and then you get the square root of 9, which is 3. And now that would turn into a 3. So what would you do with that?
Plug it into x plus 1.
Yeah. Now you would find f of, and we simplified that to 3. So you'd plug 3 in right there, and the answer would be 4. Okay, so we don't have to go through all the steps, but that's numerically what we're doing. Okay, we're not going to be doing it with numbers. We're going to be doing it with variables.
Can you just go over what inside function means again?
Yeah, let's do it. Let's do it with this problem. Let's practice just composing them one more time, and then in the next problem, which is down here, we'll find the domain. And I'll talk about the inside function again. Anyone think they could tell me f of g of x? Let's take a look. So we're taking g, plugging it in to f.
So it'll be the square root of x plus 1.
Yep, square root of x plus 1. How about g of f of x?
Square root of x plus 1.
Can you tell me how to write it though? Because it sounds like the same thing we just wrote, but it's not. What did you write down?
Like it's all under the same. It's
Yes.
all square root.
So they're both square root of x plus 1. The difference is fg of f, it's all under the square root. Because you're taking all of this and replacing the variable. Okay, so any questions on that idea? That's the composition. All right, so now let's look at the domain, and we'll talk about the inside function again. Let's just do this one way. Let's just do f of g of x. So we'll make that f of g of x. So f of g of x, take function g, plug it in for the variable. So I get the square root of x squared minus 1, similar to one we just did. Any question on that? Now, what does that simplify to? X minus 1. Now, if you were trying to figure out the domain and all you do is look at the final answer, you're going to get it wrong. You have to remember something about the inside function. Okay? G is the inside function here. It's the one that's in the parentheses. So go back to the inside function and look at the domain. Function G. That was the square root. Is there anything I need to be careful about plugging things in for x in function G? I can plug in 0.
It can be a negative.
But I can't plug in a negative. Okay? I can pick any number from 0 to infinity. All right? So we can't include negatives. Remember that. And now look at the final answer. Are there any numbers you're not allowed to subtract 1 from? No. So there, in this problem, you don't get any new restriction from the final answer. The only restriction comes from this part. The first part. Okay. So the first part, we looked at it, we just said don't include negatives. So the domain here is from 0 to infinity, which again, you do not get by just looking at the final answer. That's part of it, but you also have to look at the inside function. Is there any questions on what I mean about inside function now? All right. I'm not going to do it the other way. All right, so the range, well, I use the calculator to help me with the range. But the first thing I like to do is figure out the domain, because that tells me an idea about my x min and x max on the window. If I don't know my domain, I'm not going to be sure where to set my window. So figure out the domain. And then using the graphing calculator, we'll determine what values you get when you plug in those x values. So remember, the domain is the numbers you plug in for x. The range is what answers do you get for y. Again, this one says to do g of f and f of g. We'll pick one. Without even knowing what the functions are yet. You want to do g of f or f of g?
F of G.
F of g. So we're going to do the second one. We'll see what the functions are in a second. Okay, so let's find f of g. take function g, plug it in for the variable in f. And if I do that, Mallory, could you tell me what I would get? So if I find f of g, what would I get for my answer? Can you say the first part again? Yep, the square root of x minus 3. Perfect. There's your answer. Domain. Start with the inside function. Look at g of x. Is there any value you cannot plug in for x in g of x? Mike? Nope. You can take any number you want and subtract 3. You only have to be careful with square roots and division. If it doesn't have that, you're good. So there's no restriction from the inside function. But now we have to do step 2, which is look at the final answer. Are there any restrictions I need to be careful about in the final answer? Yeah. Can't have a negative number under the root, so you'd have to pick a value for x 3 or higher. Okay, it's got to be a value 3 or higher. In the range, let's graph and see what it looks like. So remember, range is the y values. How high and low does this one go? All right, let's see. So what does it look like the lowest that this ever goes on the y-axis? Yeah, it'll go down to 0. That's the lowest. And how high is that graph going to go? To 3? Well, let's look further to the right and see if it goes above 3. Does it go above 3? Yeah. How high would it go if I just keep looking further and further? Forever. This graph is going to just keep going up. You can, because as x gets bigger and bigger and bigger, you just keep taking the square root of a bigger and bigger number and getting a bigger and bigger answer. Okay. So there's your domain and range. Any question on that one? So try to use the calculator to help you out. That'll give you an idea, if you can see it, what the range is. Don't worry about that. We already mentioned that. I'm going to summarize what was just on that other page right here. So we have this, and then the word problem, and then we're done. So we talked about all the transformations yesterday. And we talked about shifting up and down, shifting left and right. And I told you they all apply to any function we study. That's all I'm writing right now. So when I write down what I'm about to, I'm going to use the letters A, H, and K. Those 3 variables have to be in that set. What does that represent again? All positive real numbers. So I'm talking about any positive real number you want. Okay, if you want to do a vertical stretch or shrink, you take and put a number in front of the function. Yesterday it looked something like this. That's a vertical stretch by a factor of 2. I could also do this. That's a vertical stretch by a factor of 2 for the square root function, okay, for any function. How did we shift up or down? Where did we put a number to shift up or down?
in parentheses.
So can somebody tell me how you would shift this up 3? X squared. Mhm. Yeah, go ahead. Yeah, just put a plus 3. So if you put a plus on the end, it would go up 3. What if you made it a minus? Down 3. That's why I just combined them into the same thing. Plus or minus on the end would shift it up. What if you wanted to shift left? What do you do there? In parentheses, yes, you do the plus. So like in the parentheses, if you put a plus, that would shift left. What about right? What would you change?
Negative.
Yeah, make the plus a minus. And the last 2 things we talked about were reflections. If you put a negative in front, that will flip the graph over the x-axis. If you put a negative on the inside, that would flip it over the y-axis. This is the one we didn't look at a lot yesterday because parabolas are symmetric over the y-axis. So you can't really tell when you do this with a parabola if you don't shift it from the origin. Okay, so any questions on what the transformation is and what it looks like where you put the number to do the transformation? All right, so kind of thing you might see is something, and I'm going to just simplify this a little bit. Let's say that picture is f of x. I want you to find that. So the first thing you have to understand, you don't even have a formula for it. All you know is you're taking and transforming it, doing 2 things. Can someone tell me what the plus 1 is going to do? Yeah? You're going to move it left 1. So all you would do, if that's your picture, just take and slide it left 1, like this. And draw it again. That's the first transformation, but that's not the final answer. What else do they ask me to do after that?
Down 3.
Right, you have to know that when you put a number at the end, you're taking whatever you have and moving it down 3. So down 3, down 3, down 3. So what's in green that's the final answer. So it's taking a graph and transforming it. You won't have a formula. You're just going to have a picture. You just have to move it. Okay. Any questions on that? Yeah. Go back up to the chart because that's that was the last one for today. Okay, so that's how you can create new functions, but the focus is on figuring out, when you do that, what did you do to the domain? What did you do to the range? Okay, so homework tonight on page 66. And yeah, try all those. Okay, 1, 2, 3, 6, 8, 13, 15, 32, 40, 44, 57, and 63. That will be the last homework assignment for this week. Tomorrow night, we'll do the take-home. Remember, you have 24 hours from when you get the take-home to when it's due. What happens if you don't get it to me in 24 hours? 0.